Hey, today I'm going to show you how to solve logarithmic equations. Let's jump into it. So the topic of solving logarithmic equations can be broken up into two different cases, case 1, case 2, and also probably a combination of both of them. So this video is going to talk about case 1, then I'm going to do a separate one on case 2, and possibly a third. Here we go. With solving logarithmic equations, you do need to know certain rules already. So you do need to know how to expand and contract your logs using rules like this. If you have a log to some base of a times b, we know that that's equal to the log of that same base, x, of a plus the log same base of b. So when we multiply, it equals adding of logs. Or in the reverse, if we have two logs adding, we can rewrite that as one log with the insides multiplying. Okay, so if you don't know these rules already, I recommend you go back and review those rules because they're going to be essential for solving logarithmic equations. These rules are for simplifying logarithmic expressions. So it's very important. So either I'll do another video on that or I'll attach some PDF with all the rules that you have, okay? So moving on, case number 1, we're going to call it. Case number 1 is using the relationship of exponential equations and logarithmic equations and the fact that they are inverse equations of each other. So what we're going to be using is this relationship that if we have an exponential equation, so some base to some exponent equal to some number, right? We can rewrite this as an equivalent form as its inverse, which is the log, same base of that same number equal to the exponent, and vice versa. We can take this logarithmic equation and convert that back to its equivalent exponential form. So this is the rule or the case that we're going to be using here, where we have logs on one side of the equation. Okay, when we have logs on one side, like this, equal to some number on the other side, right? In this case, the number is going to become the exponent of the exponential equation we convert things to. If we have this case here, then we know exactly what to do every single time. So, for an example, if we had log base 2 of x equal to 5, something that we can't punch into our calculator, and there's no real steps in terms of solving. It's not like we can separate the log or the 2, divide, multiply, anything like that. Nothing works here. So our only way out of this is to convert this into exponential form. And again, how do we know this is case 1? Because we only have a log on one side of the equation and a number on the other side of the equation. So what we do is we say, all right, the base is 2, the number, or the exponent, sorry, is 5. So equals the number, which is there, which is x. So exponent, number, base. And now we just do 2 to the 5th, which is 32, which is x. And we've solved this logarithmic equation. No problems. So now, obviously, we can make this a little bit more challenging by adding more logs to the expression, or to the equation. So if we had log base 2 of x plus log base 2 of x plus 3 is equal to 2. Now again, this is case 1 because we have logs on just one side. Okay, yeah, there are multiple logs, but they're only on the left side of this equation, and we only have a number on the right side of the equation. So again, what we're going to use happens to be the rule I put up top here. Okay, when we have logs adding to each other, we can rewrite that or simplify that down to a log base 2 of x times x plus 3, right? The two insides multiplying each other equals 2. Okay, now what? Well, we can simplify inside the log, so we're going to get log base 2 of, we're going to distribute that x. So x squared plus 3x equals to 2. Now we are in our form that we want, 1 log equal to some number, right? Case 1. So we're going to convert now into exponential form. So we have 2 is our base, that number. And this 2 over here becomes the exponent equals the number x squared plus 3x. It's whatever's inside those parentheses there, okay? Now, I know I'm running out of a little space here and I don't want to start over, so we're just going to move it up here. We have 2 squared equals x squared plus 3x. Now that we are out of logarithmic form, it's time to reevaluate. So once we've switched it from logarithmic form to exponential form, the form changes just again, right? After we square that 2, I look at my expression here and I notice we have x squared. So this is a quadratic equation. So if you saw my video on solving quadratic equations, you'll know what to do. It's set it equal to 0. So we're going to subtract 4 from both sides. And I'm just going to kind of rewrite things a little bit. So we're going to have x squared plus 3x minus 4 equals 0. We're going to factor. This is a double bubble form, because we have a 1 in front of the x squared, so we get what multiplies to -4 and adds to 3. So we're going to get x plus 4 and x minus 1. We do our t-chart, and we get x equals -4 and x equals +1. Now, what's important, why I wanted to solve the whole thing down here, is because of this part here at the end. With logs, we need to check our answers more than ever, because with logs, negative answers are not acceptable. They are undefined, but not a negative number answer. So this could work, x equals -4, but what doesn't work is if I plug that -4 into one of my original logs and I have a negative inside. So obviously if I plug in x here, I have log base 2 of -4. That's an undefined answer. If you punch that in your calculator, you're going to get an error. Same thing if I plug -4 here, I get log base 2 of -1, right? -4 plus 3. Again, we're going to get an error. So if I get an error with either one of these logs based off of one of my answers, we have to reject it. So my only answer for this is x equals 1, okay? So remember, it's not the fact that x is equal to -4, it's the fact that when I plug it into the logs that it becomes or stays negative inside the log. So just as easily, we could have a positive answer that when I plug it into the logs makes the log negative inside, again, making it undefined, or have an error, so it's not an answer, okay? So you have to make sure you plug your answers back into the original just to make sure. Okay, so this is case 1. I hope it made sense, and you can identify when we have logs on one side, this is the approach that we're going to work with, okay? So I'm going to stop this now, and we're going to move on to part 2, which we're going to talk about case number 2, okay? And maybe I'll talk about this background when in that video there. All right, so see you guys later.